So from this chapter, as you know, the total marks for this chapter is 14. Okay, so 1 marks, 2 questions are asked. Okay, that is MCQs, and 3 marks, 4 questions. So out of 4 questions, 2 are theory-based questions and 2 are numericals. Okay, so as you know this, so in the previous class, we have discussed the synopsis part, and we have seen the MCQs. Okay, so today we are going to see the 2 marks question. Fine. Okay, so shall we start? Yes. So the first question which we are discussing is, mention any 2 factors on which conductivity of an electrolyte solution depends. Okay, so this is a question. Mention any 2 factors on which conductivity of an electrolyte solution depends. Yes, what are the 2 factors on which the conductivity of an electrolytic solution depends? Yes, what are the 2 factors? So this question is for 2 marks. So 2 factors, each factor 1 mark. Okay, so if you write only 1 factor, you will get 1 mark. So if you write both the factors, you will get 2 marks. Okay, like this. So what are the factors? So the factors, so we have seen what is conductivity. Okay, we have seen what is specific conductivity, what is molar conductivity, right? So the factors on which the conductivity of an electrolyte depends is the nature of electrolyte. Okay, the first point is what? Nature of electrolyte. So please write it down. I hope you are carrying your pen and a notebook. Okay, so the first factor is nature of electrolyte, and the second factor is concentration. Okay, concentration of the electrolyte solution. What? Concentration of the electrolyte solution. Okay, so these are the 2 factors. So these are the 2 factors on which conductivity of an electrolyte solution depends. Okay, so these 2 factors, if you write, you will get 2 marks. Okay, so the next question is, what is the effect of dilution on conductivity? Give reason. So we have seen this. Yes, we have seen this. What will happen to the conductivity upon dilution? Yes. What will happen to the conductivity upon dilution? So here you can see, yes, what will happen to the conductivity upon dilution? So as you increase the dilution, okay, as you increase the dilution, the conductivity will decrease. Yes, you can read it out here. Yes. So what will happen? So as you increase the dilution, what will happen to conductivity? The conductivity will decrease. Okay. So the conductivity will decrease. So what is the point? So you have to mention. So what is to be mentioned here? So what is the effect of dilution? Okay, they have and they have said you have to give the reason. Okay, so what is the effect? So conductivity, it decreases. Okay, conductivity, it decreases with increase in dilution. Why? Because it depends on what? It depends upon the number of ions. Okay, so because the number of ions, so I'll write it here, please note it down. So what is the effect of dilution on conductivity? Conductivity decreases. Okay, conductivity decreases with increase in dilution. Okay, why? What is the reason? Because number of ions per unit volume decreases. Okay, because the number of ions per unit volume will decrease. So this is the effect of dilution on conductivity. Okay, so these are the 2 questions. So very important questions. Okay, so the next question is, what is the effect of dilution on molar conductivity? Give reason. So either of the question can be asked. Either it will they'll ask you the effect of dilution on specific conductivity, give reason, or they'll ask you what is the effect of dilution on molar conductivity. Yes, what will happen to molar conductivity, students? Yes, what will happen to the molar conductivity when you do dilution? So what will happen? Molar conductivity will increase. Okay. So it will increase. So molar conductivity, it increases. Yes, it increases with uh, increase in dilution. Okay. It increases with the increase in dilution, because what will happen? Because the total volume, okay, the total volume of the solution containing 1 mole of electrolyte increases, because the total mole of solution, okay, the total volume of solution containing 1 mole of the electrolyte, it increases. So this is the reason. Okay, I hope you are getting this. Yes. So we are discussing your 2 marks questions. Okay, so these are some of the important questions which are asked repeatedly. Okay, so these are marked as some of the important questions. So these are the questions you have to read. Okay, so so we have seen just now what is the effect of dilution on molar conductivity. Okay, so the next question is the conductivity of 0.025 normal solution of methanoic acid is 1.1525 Siemens, okay, Siemens per meter. Calculate its molar conductivity. Okay, calculate its molar conductivity. So how do you calculate the molar conductivity? Molar conductivity is given as, okay, it is given as 1000. So molar conductivity is equals to 1000 into its conductivity. Okay, so the conductivity is given divided by the conductivity of the solution is given as what? It is given as so C. Okay, so what is the values? Okay, so 1000 into K is your 1.1525. Okay, divided by C is 0.025. Okay, 0.025. Fine. So this is the what you say? This is a substitution part. Okay, this is a substitution part. Yes. So substitute and tell me the answer. What you are getting? Okay. What is answer you are getting, students? Just check. 1000 into 1.1525 you do. First you do 1000 into C, and for the exams, okay, you can take a simple calculator. Do you know that? So you can use a simple calculator. You cannot use a scientific calculator. You can use a simple calculator for your calculation. So you can take a simple calculator. Okay, you have to carry your own simple calculator. So with the help of simple calculator, you can do the calculations. So do the calculations. 1000 into 1.1525 you do first, and then you divide whatever the answer you get, you divide it by 0.025. Yes, students, what answer you are getting? Yes, YouTube students, you can also answer in the chat box. Okay, please give your answers in the chat box. There should be interaction. Yes, what is the answer? Very simple calculation. Okay, very simple calculation. So the answer, it comes as 46,100 Siemens meter square per mole. Okay, Siemens meter square per mole. Yes, yes, it is 46,100. Good. So 46,100 Siemens per, that is Siemens meter square per mole. Okay, Siemens meter square per mole. So this is the your units. Okay, please write the unit also. So for the formula 1 mark, so how is the substitution? For the formula 1 mark, and with substitution and the correct answer, you get another mark. Okay, so this is the substitution part. Yes, good. So most of you have answered it right. Very good. Okay, So coming for the next question. So the fifth question, 1 molar solution. Okay, 1 molar solution of a salt surrounding two platinum electrodes 2.1 centimeter apart and 2 centimeters square in area was found to after a resistance of 50 ohm. Calculate the conductivity of the solution. So how do you calculate the conductivity? They have asked to calculate the specific conductivity. Okay, how do you give the specific conductivity? Specific conductivity is given as L into area of cross section into 1 by R. Okay, that is your conductivity. Okay, resistivity is given. Okay, because they have given 1 molar solution of salt is surrounding the two platinum electrodes, which is 2.1 centimeter apart and 2 centimeter square in area. Okay, so what is the length? It is given as 2.1 centimeter. Okay, and what is the area? So area is equals to 2R. Okay, so this will be 2.1 into 2. So this will be what? It will be 4.2 centimeters square. Okay, so this is the area. We have to calculate the area. Okay, then next things, what you have, resistance is given. It is 50 ohms. It is 50 ohms. Okay, now substitute. L is what? 2.1. What is area of cross section? 4.2 into 1 divided by 50. Yes, now you do this. Do this calculation, students. What answer you are getting? Just check. Okay, I've got the answers here. Okay. Okay, 0.01. Yes, 0.01 is the right answer. So the unit is 0.01 Siemens per centimeter. Okay, Siemens per centimeter. So this is the answer. Okay, I hope this is clear. So for the formula, 1 mark, and for your substitution, your answer. Okay, for your answer with the correct unit, 1 mark. Got it? So these are the 2 marks question. So next question, state Kohlrausch's law of independent migration of ions. Okay. So for this law, 1 mark, and write the mathematical relation for limiting molar conductivity of calcium chloride. So you have to state the law. Okay, for the law, you will get 1 mark, and for the mathematical relation for the limiting molar conductivity of calcium chloride, you get to write that mathematical relation, you get 1 mark. Okay, so what is the law? Yes, what is the law? That is the Kohlrausch's law of independent migration of ions. So the law states that limiting molar conductivity of an electrolyte. Okay, the limiting molar conductivity of an electrolyte, it is equal to what? It is equal to the sum of the ionic conductance of your cation and anion. Okay, that is your respective cation and anion. So this is the answer. So what is the answer? The limiting molar conductivity of an electrolyte is equal to the sum of the ionic conductance. Okay, ionic conductance of their cations and anions. So this is the law. This is the law, Kohlrausch's law. And what is the mathematical relation for limiting molar conductivity of calcium chloride? So it is given as, so the limiting molar conductivity, yes, yes, how to write it? So it is given as lambda, okay, not calcium chloride equals to lambda calcium plus. Okay, so this is 2Cl2. So this 2 will come up, okay, and you will write lambda naught Cl minus. So this is the mathematical relation. Okay, like this you are going to write. mathematical relation to represent your limiting molar conductivity. Yes, is it clear? Yes, is it clear? Fine. So this is the law. What is Kulrash's law? The limiting molar conductivity of an electrolyte is equal to the sum of the ionic conductance of their cations and anions. Okay, and the mathematical representation for calcium chloride. It is given as what? It is given as this. Okay. Now I'll give you another. Can you tell me the mathematical expression for limiting molar conductivity of NaCl? Yes, students, how to write for NaCl? How to write it for NaCl? How do you write for NaCl, students? Yes, how do you write for NaCl? Lambda naught. Okay, lambda naught of NaCl is equals to lambda naught of Na plus and lambda naught of Cl minus. Okay, so like this. I hope it is clear. Okay. So moving further. Yes, good. Yes, Abhishek has answered it right. Good. Okay. So moving further, next question. Name the gases liberated at anode and cathode when an aqueous solution of sodium chloride is electrolyzed. Yes, name the gases liberated at anode and cathode when an aqueous solution of sodium chloride is electrolyzed. Means what? When you have taken sodium chloride, okay, you have taken sodium chloride in a beaker and you have passed what? You have passed electric current, okay, and there are two uh, electrodes. So one reaction, so you have passed what? You have passed the electric current. Okay, so upon passing the electric current, what are the gases liberated at this anode and at the cathode? Yes. And which is the electrolyte? NaCl is taken. So which is the electrolyte? At anode. Okay. At anode, what will get liberated? Yes. Is the screen visible, students? Okay. Yes. Okay. Fine. So we were discussing about the gases. Okay. So which are the gases which are liberated at anode and cathode? So at anode, your chlorine gas is liberated. At anode, chlorine gas is liberated. And at cathode, your hydrogen gas is liberated at cathode. So hydrogen gas at cathode. So if you write at anode, the gas, if you write properly, so 1 mark for that. And at cathode, if you write hydrogen gas properly, okay, you get another mark. So like this. Fine. Next is write a diagram of Daniell cell and write the half cell reactions. Yes. What is the so what is the half cell reactions? Yes, what is the half cell reaction? So did you see the Daniell cell, how it looks? So for the diagram, okay, how the marks are given for the diagram, 1 mark, okay, and for the half cell, yes. So the reactions, okay, the two reactions. So at cathode reaction is one half cell reaction, and at anode, okay, the reaction which is occurring is another half cell reaction. So these are called as the half cell reactions. Okay. So at anode and at cathode. So how do you draw the Daniell cell? So you have to take, so please see the diagram. Okay. Very important. So take two beaker. Okay, what all should be important? Just see. Okay, I'll draw it a little closer. Okay, so take two beakers. So in your this beaker, I take a zinc rod. I take a zinc rod, and in this I take my copper rod. Okay, so this is a, so I have to name it. So this is a zinc plate, and this is a copper plate. This is what? This is a copper plate. So zinc plate, okay, this is anode, and at cathode we are taking copper. So remember, okay, zinc and copper is there. So copper, C copper you have taking at cathode, okay, and another at anode will be zinc. So C and C, remember like that. Copper at cathode, and at anode you are taking zinc. So zinc is dipped in what? It is dipped in zinc sulfate solution. It is dipped in what? It is zinc dipped in zinc sulfate solution, which is of 1 molarity. Okay, 1 molarity. Then copper is dipped in what? Copper is dipped in copper sulfate solution. Copper sulfate solution, which is of 1 molarity. Okay. Now, this two anode and cathode, they are connected by a battery. Okay, V. So voltmeter is connected here, V. And these two, how the passing of ion takes place? By placing a salt bridge. So we are passing a salt bridge so that the transfer of or the movement of ion takes place. Yes, okay, the transfer or the movement of ion takes place. So this is our, so you have to, so right here, okay, this is salt bridge. So you have to name it properly, okay. So this is the correct way. So draw it properly. Two beakers, two plates, their respective electrolytic solutions, electrode with the electrolytic solution, this concentration, 1 molarity, that should be maintained. Then salt bridge. Okay, so these all things should be written. Fine. Now, so for this diagram, proper diagram with proper representation, 1 mark. And what are the two half cells? So at anode and at cathode. So what are the reactions which are occurring? So at anode, okay, at anode, what is happening? There will be loss of electron. Okay, that will be oxidation takes place at anode. Okay, so what is oxidation? Loss of electron. So Zn giving you Zn plus 2 electrons. Okay, so this is the reaction at anode. Then at cathode, what takes place? At cathode, reduction takes place. There is gain of electrons. So copper plus 2 electrons, it gives you copper. Okay, so this is the reaction. So for the reaction, 1 mark, and for the diagram, 1 mark. Is it clear? Is it clear, students? Okay, so like this, for the diagram, 1 mark, and for the half cell reaction, 1 mark. Okay, very important. So Daniell cell, then standard hydrogen electrode. So that also is very important. So that we are going to see later. So Daniell cell is also important for 2 marks. Okay, practice the diagram of Daniell cell and their half cell reactions. Very simple. Yes. Is it clear? Yes. Good. So these are the things. Next question is state Faraday's first law of electrolysis. Give its mathematical form. Yes. Anybody wants to state the first law of Faraday? Yes. Anybody wants to tell the first law of Faraday? What is first law of Faraday? So there are two laws. Okay. First law and second law. But first law is asked like in most of the things. Okay. In the most of the times, first law is asked. So first law we will study. So what is the first law? Faraday's first law, students? Okay, good. Abhishek has answered. So it states that during the electrolysis, the mass of a substance deposited at an electrode is directly proportional to the quantity of charge which is passed to the electrolytic solution. Yes, good. Okay, so good. So the statement is right, Abhishek. So this is the, yes. Sita wants to answer. Yes, you can give your answer. Yes. Anybody else? You can give your answers. Okay. So this was the first law of electrolysis. So whatever the amount of substance, okay, which is liberated at the electrode is directly proportional to the quantity of electricity which is passed to the electrolyte. So how much amount of electricity is you're passing to the electrolyte, that much amount of the substance is liberated. Okay, it is directly proportional. So the quantity to the electrolyte. So how much amount of electricity is uh, is used, it is passed. So it depends upon these two things. So it is given as what? So W. So W is directly proportional to Q, that is the charge. So W, if you remove this proportionality sign, okay, you will introduce Z and Q. Fine. So these are the, so this is a mathematical form. So you need to write this mathematical form. So for the mathematical form, you get 1 mark. And for the first law, you get, for the law, okay, you get 1 mark. I hope this is clear. Okay. So the last question, draw a half, sorry, draw a graph of lambda m versus square root of c for acetic acid and HCl solution. Yes. So acetic acid, it is a weak electrolyte solution. So acetic acid is what? Acetic acid is a weak electrolytic solution and KCl is a strong electrolyte. Okay. KCl is a strong electrolyte. So yes, good. Srushti has also answered it right. Good. Okay. So, so we are seeing the next question. So we need to write. So it can be, this question can be asked for 2 marks or it can be asked for 1 mark. Okay. So the 3 marks question, what we are, so the 3 marks question, what we have seen. Okay. You have a 3 marks question, theoretical part. So directly 3 marks question won't come. It will be in the form of 2 plus 1. Okay. So that time you can get a 1 mark question like this also. Draw a graph of lambda m versus square root of c for acetic acid or KCl solutions. So you have to practice both of them for the strong electrolyte also and for the weak electrolyte. So for the acetic acid, okay, so for the acetic acid, so the graph will be like this. So here you take root of c and here it will be m of, so this, so the curve will be like this. Okay, the curve for acetic acid is like this. So please draw this. Okay, please draw this, very important. And for the other, that is a strong electrolyte. So it will be square root of c here, and this is the okay. Then how this will be? It will be like this. Okay. So this is for KCl. So draw this two. Okay. For the graph, you will get 1 mark each. Okay. So based on the type of question asked, you have to answer it. I hope you are getting it. Yes. So what is to be answered? Is it fine? Okay. So moving further, okay. So next is the 3 marks question. Okay, next are the 3 marks question. So the first question is, so very, 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 very important. Okay. So as I've said, to practice the Daniell cell, so you have to practice this also. Construction and working of standard hydrogen electrode. Okay. So explain the construction and working of standard hydrogen electrode, or it can be asked in other way, like draw a neat label diagram of standard hydrogen electrode and write its symbolic representation and write their half cell reaction. Okay, so like this, the question can be framed. So these are the type of question in which it can be framed. Okay, so either they'll ask you the construction and working of standard hydrogen electrode, or they'll ask you to draw the label diagram and write its symbolic representation, that to write the representation of the cell and to write their half cell reaction. Okay, so how do you write this now? So what you have to write? So SHE. So you need to mention that SHE, it consists of what? It consists of a platinum foil. It consists of a platinum foil. Okay. Which is coated with platinum black. So this platinum foil, it is coated with platinum black. So this platinum foil is connected to platinum wire, okay, with mercury. So this, whatever the platinum foil is there, it is connected to platinum wire, which is with mercury. So the other end of the platinum wire, it is connected to external circuit. Okay, it is connected to what? It is connected to external circuit. So this platinum foil which is there, it is dipped in 1 molar HCl solution. It is dipped in 1 molar HCl solution. So how is the diagram? Yes, how is the diagram of this SHE? So it is like this. So take a beaker, okay, draw a beaker. So I'll just show you. Okay, so this is a platinum wire which is there. So from here, your H2 gas, which is 1 bar. Okay. Then from here, so here 1 molar HCl solution is there in this. Okay. Now from here, what is pumped? So your finely divided platinum coated on platinum foil. So on the platinum wire, what is coated? The foil is coated. Okay, like this. Here you can see. So on this wire, the platinum foil is coated with platinum black. Okay, and it is dipped in a HCl. So this is your what? This is your diagram. Okay, this is the diagram. So this is the label diagram you have to draw. Now, what is the working? So this is the construction. Now working, how is the working? So you have to pass the pure and dry hydrogen. So from here, what you have to do, you have to pass from this outlet. Okay, from this point, what you have to do, you have to pass pure and dry hydrogen gas, which is at 1 bar pressure. Okay, from the from inlet electrode reaction is, so what is the inlet electrode reaction? So the inlet electrode reaction is H plus aqueous plus electron, okay, giving you half H2 gas, giving you half H2 gas. Okay, now how is the representation of SHE? So this is the half cell reaction, very important. Okay, so the diagram, working, and the construction part. Okay, that is, this is a construction part. So now the representation of SHE, it is given as what? How is the representation of SHE? Can anybody, students, you can try. How is the this? It is given as platinum, which is solid. Okay. It is dipped in what? It is dipped in hydrogen gas, which is at 1 bar pressure. Okay, at 1 bar pressure. So this is dipped in H plus, that is aqueous solution of H plus, which is of 1 molar concentration. Yes. So like this. Is it fine? So this is for 3 marks. So for the construction and diagram, 1 mark. For the representation, 1 mark. That is symbolic representation, 1 mark. And for the cell reaction, 1 mark. Like this. So the marks are distributed evenly. Okay. So if you do not draw the diagram, your 1 mark will be deducted. If you do not write the cell representation, your 1 mark will be deducted. Like this. Okay. So depending upon what they ask. So if they ask you the construction and working, so you have to mention these all things. So mention the construction, draw the diagram. Okay. Then draw the, write the cell reactions and write the symbolic representation. Okay. So like this, you can fetch the 3 marks. Okay. So the next question, calculate the EMF of the cell in which the following reaction takes place at 298 Kelvin. Okay. So this is the reaction. So what is the EMF of the cell of the following reaction which takes place at 298 Kelvin. So this is a cell reaction which is given as nickel solid plus 2 Ag plus. So this is a solution which is 0.002 molar, giving you an nickel plus 2, which is 0.160 molar plus 2 Ag. E naught of the cell is given as 1.05 volts. Okay. So we need to find the okay, EMF of the cell. So EMF of the cell is given as what? So EMF of the cell is given as E naught of cell minus 0.0591 divided by N. Okay, log of, so log of right hand side. So that is Ni plus 2 divided by left hand side is Ag. Ag plus, okay, because it is 2. So this 2 will come raised to, concentration term will come raised to. Okay. Yes, Vedvati has told it right. Good. So the cell representation is correct. Good. Okay. So this is the formula. Please note down. So EMF of the cell is a, okay. So very important. This particular formula you have to keep in mind. Okay. So on this particular formula, the question is asked. That is to find the EMF of the cell. So this is the formula, that is EMF of the cell is given as E naught of the cell minus 0.0591 divided by N. Okay. Log of, so on the right hand side, you have your nickel. So nickel plus 2 and Ag plus, so 2 is there, so that 2 will be raised to the concentration term. Now put the values. What is the E naught of the cell? E naught of the cell is given as 1.05. So 1.05 volts minus 0.0591. And what is N? N is 2. Okay, so here N is 2. So 2 electrons are evolved here. So N is 2. Then log of, what is Ni 2 plus value is given. It is given as 0.160 and divided by what is log of Ag plus, it is 0.002 square. Okay, so now solve this, students. So this will be 1.05 minus, so 0.0591 divided by 2. Okay, so just see what will be the answer. So log of, so after solving this, you get here as 40,000. So log of 40,000, just see what you're getting. Okay, I've got some answer. Okay, Abhishek has answered it as 0.9141 volts. Good. Vedvati has also answered it right. Good. Okay. Yes, Vedvati, Abhishek have answered it right. Good. So the after solving this, you get it as so 1.05 minus 0.0295 into 4.6021. Okay, after solving this, you get it as 0.914 volts. Okay, 0.914 volts. So this is the correct answer. Is it fine? So how is the mark distribution? So for the correct formula, this particular formula, you get 1 mark. Okay. Then for the correct substitution, all the 3 steps. Okay, stepwise you have to solve. How I have solved, no, like that. So after one substitution step, you cannot directly write the answer. You have to show all the substitution. Okay, stepwise you have to show the substitutions. So how I have shown substitution. So how log of 0.160 divided by 0.002, it becomes 40,000. Okay, you have to solve this. Then you have to convert it like this. So all these steps should be mentioned. So if you mention the steps, then only you will get a proper 1 mark. And last, 1 mark for the answer with the unit. So if you do not write volts, your 1 mark will be deducted. And if you half mark won't be deducted in chemistry. Okay, directly 1 mark will be deducted. So like this. Okay, so you have to write the answer also and the unit also should be mentioned. If you write the correct answer but still units are not written, your 1 mark will be deducted. Okay, so only for the correct formula and the proper substitution, you will get only 1 mark. One mark each means 2 marks. So for the answer, you'll lose the mark if you do not write the units. Okay. Next question. Calculate the value of delta G naught at 298 Kelvin for the cell reaction. Cell reaction is given 2 Mg plus 2Al plus 3 aqueous, giving you 3 Mg plus 2 aluminium. Okay. So E naught of Mg is given as minus 2.36 and E naught of Al aluminium is given as minus 1.66 volt and Faraday value is 96.4 87 coulombs. Okay. So how do you find it? So first you have to find the E naught of cell. How do you calculate the E naught of cell? You have to calculate the value of delta G naught. Okay. So to calculate a delta G naught. So delta G naught, the formula Gibbs energy. Okay. It is given as what? Minus N F E naught. Okay. So first you have to find out the E naught of cell. So how do you calculate the E naught of cell? E naught of cell is equals to E cathode minus E anode. So E cathode is your what? Aluminium. Okay. So at aluminium, what is there? So E naught of aluminium minus E naught of Mg. Okay. So what is E naught of aluminium? What is the value? E naught of cells are given. Aluminium is minus 1.66 minus of then this E naught of Mg is minus 2.36. Yes, what is the answer? This answer comes to be minus 1.66 plus 2.36. Okay, it will come around 0.70 volts. Yes, are you getting the same? So this is the E naught of the cell of this particular reaction. So this is the E naught of the cell. Now, delta G naught. We have to calculate the delta G naught. So delta G naught is given as minus N F E naught. Okay, what is minus N? The number of electrons which are what involved, it is 6. Okay, 2 3s are 6. So it is minus 6 into Faraday value is 96,487. Okay, into E naught of cell is 0.70. Yes, the answer should be in kilojoules. Yes, students. The answer should be in kilojoules. Try solving this. Okay, Abhishek has answered it as minus 4.405.245 kilojoules per mole. Yes, good. Okay, yes, Abhishek, the answer is right. It is minus 405.2454 kilojoules. Okay, so this is the correct answer. I hope everybody is getting the same. What about others? Is everyone trying the problems? Yes. So for the correct formulas, and with the substitution and the answer with the unit, you get 3 marks here. So this is a 3 marks question. Okay, so this is a 3 marks question. Yes. So moving further, okay, moving further, we'll go for the next question. The electrode potential for the Daniel cell given below is 1.1 volts. That is the zinc solid dipped, dipped in Zn plus 2 aqueous. Okay, this represents your salt bridge. Copper plus 2 aqueous dipped in copper, that is with your copper rod. Okay, write the overall cell reaction and calculate the standard Gibbs free energy. So here they have asked you to calculate the standard Gibbs free energy for the reaction. So Faraday value is given. Okay, good. Srushti, so for the previous question, Srushti, Umbra, Vedvati has answered it right. Good. Okay. So now we are solving the next question. So this is the Daniel cell. So you have to find the standard Gibbs free energy. Okay. So Zn, I'll write the reaction. So Zn plus copper plus 2. Okay. Aqueous giving you Zn plus 2 aqueous plus copper solid. Okay. So delta G naught. So what is standard Gibbs free energy? Delta G naught is equals to minus F and E naught of cell. Okay. Now what is minus this? N is represents your number of electrons which are involved. So this is 2. Okay, 2 electrons. Then Faraday value is 96487 into what is the E naught of cell? E naught of cell is given as 1.1 volt. 1.1 volt. Yes, see what is the answer you are getting, students? What is the answer you are getting? Yes, what is the answer you are getting? Delta G naught. Okay. Vedvati and Shushti have answered it right. What are the units? Please answer in units. Okay, units are also important. It is minus 212.271 kilojoules. Please mention the units. Units are very important. Write small k. Okay, yes, write small k kilojoules. Okay, so this is the way. So as I've mentioned you, if you do not write the units, your marks will be deducted. 1 mark directly will be deducted. Okay, so please mention the units. Units are very, very, very important. Yes, I'm getting the answers. Srushti, Abhishek, Surekha, Nikita, Srushti, then Vedvati. Yes, good. All have answered it right. Good. Okay. So this is the way you're going to solve this particular question. Next, calculate the EMF of the cell for the reaction. So this is a reaction given Mg plus 2Ag plus aqueous, giving you Mg plus 2 aqueous plus 2 Ag. So the E naught of Ag plus Ag is given as 0.80 volts. E naught of Mg plus 2 Mg is given as minus 2.37 volts. Mg plus 2 is 0.001 molar, the concentration, and Ag plus is 0.0001 molar. Okay. So these are the concentrations which are given. So this should be mentioned, mentioned in the brackets. Okay. So these are the concentrations. So first is what? EMF of the cell. So for the EMF of the cell, we want E naught of cell. Okay. We do not have E naught of cell. E cathode, E anode reactions are given. The values are there. So from this first, we are going to find the E naught of cell. E naught of cell is what? E cathode, E anode. E naught of cathode is what? E naught of cathode, the reaction is Ag. So E naught of Ag minus E naught of Mg and Mg. Then what is E naught of Ag? That value is 0.80 minus 2.37. Yes. See what your answer you're getting. So 0.80 plus this will be 2.37. So this is the E naught of cell. What the E naught of cell you are getting? Just check, students. Okay. Vedvati has got it as 3.17. Yes, it is good. Right. So it is 3.17 volts. Okay. 3.17 volts. Fine. So now, so E naught of cell is given. So what is E cell? E cell is given as E naught of cell minus 0.059 divided by N log of what is Mg 2 plus divided by Ag plus. Okay, sorry, 2 is there. So it is raised to 2. Now, E naught of cell is 3.17 minus 0.059 divided by 2 ones are. So this is 2 log of Mg plus 2 is 0.001 0.0001 square. Okay. Yes, solve it, students. Okay. Vedvati has answered it as 3.02. Okay. So we'll check. Yes. So I'll check it now. So 3.17. So I need a stepwise. Okay. So the answer of how you are solving the stepwise, it should be solved. Okay. So now this is, so this can be written as 10 raised to minus 3. Yes. 0.001. So when I shift this decimal this side, so it becomes 10 raised to minus 3. And this becomes 10 raised to minus 4. Okay. And square root. So if I represent like this, so I'll write in this way. Okay. I'm representing just in raised to manner. Okay. So 3.17 minus 0.059 divided by 2 log of. So when 10 raised to minus 3 and this is 10 raised to 8. So it transfer up. So 8 minus 3 will be 5. So this becomes 10 raised to log of 10 raised to 5. Okay. So 3.17 minus, so 0.0295. So after solving 0.059 divided by 2, it becomes 0.0259 into log of 10 raised to 5 is 5. Okay. So now multiply this and then you have to subtract it from. So it will be 3.17 minus 0.1475. Yes. So it will come as 3.0255 volts. So this is your E naught of, EMF of the cell. Okay. Is it clear? Yes. The answer is 3.0255 volts. Okay. Please write down. Please write it down. Yes, Srishti, Vedvati have answered it right. Good. So please copy it down. Okay. So like this, stepwise, it should be solved. For the formula, 1 mark. For the substitution, correct substitution, 1 mark. And answer with the proper unit, 1 mark. Okay. Is it right? Yes. So shall we move further? So last question. Okay. Calculate the equilibrium constant for the reaction. So there is a reaction given, equilibrium constant we have to calculate. So the reaction is copper plus 2 Ag plus aqueous, giving you copper plus 2 aqueous plus 2 AgS. Okay, E naught of the cell is given as 0.46. So how is the equilibrium constant calculated as E naught of cell equals to 0.059 divided by N log of Kc. Please remember the formulas. Remember the formulas. So EMF of the cell, Gibbs free energy, standard Gibbs free energy, and your equilibrium constant. So on these, the questions are asked. Now we have to calculate the Kc. Okay, we have to calculate the Kc. Now E naught of cell is what it is given. So it is 0.46. Then 0.59. What is N? N is 2. N is 2. Then log of Kc. So I'll take this log of Kc here. So this becomes log of Kc. Okay, is equals to. So this comes here. So this will be 0.46 into 2. Then this go at the denominator. Please solve it. So log of Kc, you get it. So 0.46 into 2 divide, and then you divide it by 0.049. So it comes to 15.5932. It comes to 15.5932. Okay, 15. So log of Kc equals to 15.5932. Okay. So Kc, so if I transfer the log that side, it becomes anti-log. So Kc is equals to anti-log of, so I have to take the anti-log. So when you want to take anti-log, so you cannot use anti-log, right? So what will be given in the, log books will be given. So in the exam hall, examination hall, log books will be given. So you have to find out the anti-log. So in the anti-log column, you have to, I hope you know to find the anti-logs. Okay. So from the graph book, you have to calculate the anti-log. So anti-log of 15.5932, it comes to 3.92 into 10 raised to 15. Okay. So this is the answer. So this is the equilibrium constant. Okay, so Vedvati have answered it right. Yes, good. Okay, so it comes to 3.92 into 10 raised to 15. Yes, others? Is it clear? Is the all the problems clear? Yes? Any doubts in today's session? Any doubts in today's session? So these are the very, very important questions from this particular chapter. Okay, so I have covered all the very important repeatedly asked questions. Okay, so we have completed the chapter solutions. Okay, so we have seen the solution chapter also. We have seen the electrochemistry chapter also. Okay, I hope these two chapters are clear. So by this, you might have understood. Okay, so what we are more concentrating on. Okay, so it will help you to score well. Okay, the students who wants to score well can so they come to know where they are failing. Okay, now so these are the little things, okay, which will add some good marks to your score. Okay, the where the marks are allotted. Okay, some students, they don't know where the marks are allotted. Okay, so like this, so these are the ways you have to follow. Okay, so these are the little things which you have to keep in mind. So this will add some good extra marks to your score. Okay, so I hope the today you have enjoyed the session today. Yes, so by solving good problems. Okay, so we have solved on each particular formula, we have solved questions. Okay, so please try to solve much more problems. Okay, and practice. Okay, as you write, uh, you will get good practice. Okay, so just reading won't help you, so you have to write it. You write, so please write and write. So whenever you are solving problems, don't just mug up, don't just look at the problems, you have to solve them. Okay, problems you cannot read them, you have to solve it. Okay, write the points, whatever are the points, please write it down. Okay, then only your it will be fixed in your mind. Okay, so yes, again, any doubts? If you have any doubts, you can ask me. Okay. Any doubts regarding the session? So by this, we have completed the chapter electrochemistry. So if you have any doubts, you can ask me. Yes, students, any doubts? Okay, fine. So there are no doubts. Okay, students. Fine. So by this, we have completed today's session. Okay. So, we'll meet in the next class. I hope you have liked the today's class. Okay. So thank you, dear students. I'll end the session here. So we'll meet in the next class. Thank you. Have a good day.